everyone. I hope your day is going great. This is Ashish from Navars and I am a program manager and astronomy educator over here. So I hope your week is going great, and I know this is a week of celebration, right? So with our cultural celebration, we have an astronomical celebration as well coming up. So astronomy. Now you might be wondering, what is this special webinar about? Many of you might already be knowing that, it is going to be on an eclipse or something, and some of you might not, have an idea on that. So for that, we have kept this special webinar. So astronomy not only helps us understand the universe, but also sparks curiosity and wonder in people of all ages, right? This is one of the most captivating examples, which is a lunar eclipse. When the shadow of the earth basically falls on the lunar surface, right? So on the night of September 7th and 8th, I repeat, on the night of September 7th and 8th, we all will all witness the first total lunar eclipse in 7 years, and that will last for more than 5 hours, right? It's a beautiful phenomenon that is going to happen, isn't it? But before we experience this awe-inspiring celestial event, let us take a moment to explore the fascinating science behind that. And well, to understand that science, from Navars, we have a very special guest today, and it is our privilege as a Navars team to welcome Dr. Niruj Mohan Ramanujam, sir.
Thank you.
Thank you, sir, for accepting our request. And so he's the head of the Science Communication, Public Outreach, and Education section at the premier institute, which is Indian Institute of Astrophysics, Bangalore. Being as a radio astronomer with a PhD from Indian Institute of Space Science, Bengaluru, Dr. Ramanujam sir has worked at leading observatories in South Africa, Netherlands, France, and NCRAT for Pune. For over 15 years, he has been a leading figure in both astronomy outreach and education, serving as a chairperson of outreach committee of both Astronomical Society of India and African Astronomical Society, and contributing actively to national and international outreach efforts of International Astronomical Union, as well as several Indian telescopes and various space mission projects. So thank you, sir, first of all, for joining our request in such a short time. And now the stage is yours, sir. That the audience is eagerly waiting for your mesmerizing webinar. Thank you.
Thank you so much. Thanks for calling me to talk about this very important and very topical subject, which is this is about a celestial event is going to happen literally a week from now. So thanks again for calling me. I was told that a lot of students on YouTube of various ages. So welcome everybody. Good afternoon. My name is Niruj Mohan Ramanujam. Like Ashish said, and I work at the Indian Institute of Astrophysics here in Bangalore. I'll share my screen now.
Yes, sir.
Yeah. And then you can tell me if things are fine.
Absolutely, sir. It's pretty much visible.
Yeah, hold on one second. There's one. Sorry, I need something going on. Just give me a second.
Yeah, sure, sir.
Hide panel. Hide meeting control. Okay. Are you seeing the full screen or are you seeing something else?
Full screen, sir.
Okay, then let's go ahead.
Yep.
So I work at the Indian Institute of Astrophysics here in Bangalore. I'm here to talk about the total lunar eclipse of 7 September 2025. So as I keep talking, I welcome all of you. If you have any questions, to please put them on the YouTube chat window, correct, Ashish? And then I think people for Navars EduTech will read them out later. If
Right.
there is if there's a question which is coming in the middle which says things are not being very clear, then you can interrupt me and tell me, and I will explain that again. Okay.
Absolutely,
So,
no problem.
fine.
Yeah, thank you.
Okay. So I work at the. So I want to say a little bit about our own institution first. We are here in a place called Koramangala in Bengaluru since more than 50 years, but we actually trace our origins back to as old as 1786, when the British started something called the Madras Observatory in present day Chennai, which functioned for over 100 years, and then it moved to Kodaikanal, where it became the Kodaikanal Solar Observatory, and then in 1975 it became our current institution called IIA. And in fact, we only celebrated the 125th anniversary of the Kodaikanal Solar Observatory only last year. So this is our headquarters here in Bangalore, where I'm sitting right now. We have observatories across India. So on the left, the bottom two images are of our observatory in Ladakh at a place called Hanle, which you might have heard of, which is one of the best sites in India for astronomy. This is a picture of the Kodaikanal Observatory and the stamp which was released just a few months ago to commemorate the 125th anniversary. We also have an observatory in Kavalur in Tamil Nadu near Vaniambadi, which has been functioning since the late 1960s, which has a bunch of optical telescopes, as you can see here. We also have a space technology, a center, a campus in Hoskote outside Bangalore, where we have made telescopes which are currently operating in space, launched by ISRO, as well as a radio observatory in Gauribidanur, which is in Karnataka as well. So just a brief introduction to our institution. If you go to our website, you get much more information. And many of our observatories are open to visitors. And if you look at our website and look under outreach and visit us, you'll find information on how to visit each of our observatories. I welcome you all to come and see us as well and look at our telescopes. And we're also building a state-of-the-art planetarium in Mysore, which will be open in a few months from now. Okay, so I was told that people are here of various ages and not everybody might know how the moon's phases occur. So I'll do a really brief introduction of the phases of the moon and then I'll move on to the eclipse. So like I said, if you have any questions in the middle which you think I need to clarify, which are very important, then please read them out and I can stop in the middle and go back to it. So this picture has images of the phases of the moon taken over a period of a month. And I'm sure all of you have seen all this. I'm sure all of you have seen the moon, of course, at night. And many of you would have seen the moon the daytime as well. On the top left, you see the crescent moon. And then the crescent moon slowly becomes larger and larger and larger. And then you have the half moon. And then the half moon, the sunlit part becomes even more than half and then becomes what is called the gibbous phase. And then you get the full moon. And then after the full moon, the sunlit part goes on the other side of the moon and you get the waning gibbous. And then the third quarter where the other half of the moon is sunlit compared to the first quarter. And then you get the crescent on the other side, followed by the new moon. And all of you, if you haven't seen all the phases, you know about them. For example, new moon and full moon are known as Amavasya and Purnima in various Purnima in various languages. The crescent moon is famous as the Eid Ka Chand and so on, right? Now, let's look a little bit as to why we have phases of the moon. Here I shown the sun in the center and the earth goes around the sun once a year, of course. And I shown you 4 locations of the earth, which is 3 months apart from each other. 3 into 4 makes 12, that is 1 year. Okay. And what I want to show you in this figure is that whichever part of the earth faces the sun is experiencing daylight, and the part of the earth which is behind on the other side of the sun experiences night. Independent of where the earth is around the sun, the part of the earth facing the sun will always have daytime and the other half will have night. And this is because the earth's light comes only from the sun. Now, similarly, the moon also shines only because of reflected light from the sun. And therefore, as the moon goes around the earth, while we go around the sun, the part of the moon which faces the sun in this image, you can imagine that the sun is on the left side and the sunlight is coming from the left as shown by the orange arrows. And therefore, wherever the moon is around the earth, it doesn't matter where it is, wherever the moon is around the earth, the left hand side of the moon is sunlit because that faces the sun, and the right hand side is dark or night. Okay. And therefore, new moon to new moon, full moon to full moon is basically 29.5 days. And therefore, depending on where you're seeing the moon from the earth, you'll see different fractions of the sunlit part and different fractions of the dark part. And because as the moon goes around the earth once a month, you're seeing different fractions of the sunlit part of the moon and the dark part of the moon. You see various phases of the moon. So obviously, if you look at the moon, which is on the leftmost center, the moon is between the sun and the earth. And the earth, if you're sitting on the earth, you'll see only the dark part of the moon. And therefore, you'll see new moon or Amavasya. If you look at the moon on the opposite side, on the right side, now the left part of the moon is having daylight. And therefore, if you're seeing the moon on the right side from anywhere on the earth, which is where you can see the moon, you'll see the entire daylit part of the moon, and therefore you'll see full moon or Purnima or Purnima. And at different other locations, you will see crescent, gibbous, first quarter, second quarter, and so on. And therefore, in this figure, if you go from right to left, for example, new moon is 0, and then you get the waxing crescent, and then a week later you get the first quarter where the right side of the moon exactly is bright, the left side is dark, and then you get the waxing gibbous. Waxing means growing. So therefore, as the daylit sunlit part of the moon becomes larger is waxing or growing. If you get the waxing gibbous, where 3/4 of the moon is sunlit, 1/4 of it is dark or night, and then you get the full moon, which is around 2 weeks after a new moon, and then you will see the other side, which is the you'll see the phase of the moon on the ulta side of the compared to the waxing phase. You get the waning phase or the reducing phase, where then you get the waning gibbous. Compare the waxing gibbous and waning gibbous. The sunlit part is on the right side for waxing gibbous. The sunlit part is on the left side for waning gibbous. Then you get the last quarter, which is the opposite side of first quarter. You get the waning crescent, the opposite side of waxing crescent, and then you get the new moon again. And this takes 29.5 days. And this is how you define a month. A month, we say the month is roughly 30 days because it takes roughly 30 days for the moon to go from new moon to new moon or full moon to full moon. That is Purnima to Purnima or Amavasya to Amavasya. And we all know about it either because you studied in your class or textbook, or because you saw it in the sky, or because you heard stories about it from your family and relatives, where we have very interesting stories about the phases of the moon. Okay. Now, therefore, to explain what I said in a video form, I'm going to play this animation. You'll see that as the moon goes around the earth, the sun is on the left side. So the left side of the earth and left side of the moon is always sunlit. But as seen from the earth, you're seeing differing fractions of the sunlit part of the moon and sunlit part of the earth, which is what is shown on the right side. So when the moon comes roughly between us and the sun, you have new moon because you're seeing the night side of the moon. And then as the moon goes down, you're seeing a little bit of the sunlit side, which is crescent. And then you will see the first quarter when it is exactly at 90 degrees, which is 1 week after new moon. And then you're again going to see the gibbous phase because you're seeing more of the sunlit side. And then when you see the entire sunlit side, when the moon is on the other side of the earth, you see full moon, which happens 2 weeks after new moon. And then you're going to see the gibbous side on the other side. And then you'll see the third quarter, where the left side of the moon, exactly left half of the moon is sunlit. And then you're going to see the waning crescent, and then you're back to new moon. I said the same thing in multiple ways, so that is clear. Okay. Assuming this is clear, and we'll move on. If there are any questions at YouTube at this moment, I can stop, else I will continue. Ashish.
We can.
Okay, we'll
So
continue.
we can.
Okay. Therefore, I talked about day, month, and year, right? So clearly, day, month, and year or calendar is connected to the sky, right? We all know that a day, you define a day by the time it takes for the earth to go around its own axis or rotate around its axis once, roughly 24 hours. We define a month as roughly the amount the moon takes to go around the earth. And we define the year as the time it takes for the earth to go around the sun, which is 365.25 days, right? And not just day, month, and year, but many aspects of a calendar. For example, various festivals of all religions are connected to the moon and the sun in the sky. And therefore, if you look at many religions and when they occur, many festivals occur, they will occur at a particular phase of the moon, for example, or a particular time when the moon is in some constellation or the sun is in some constellation and so on, like Shankranti and so on, right? And therefore, the calendar and our festivals are intimately connected to the sky, and therefore to astronomy and to the motion of the moon and the sun in the sky. Okay. And therefore, now let's look at the moon right away. The moon is around 3,475 kilometers in diameter. The earth is 12,742. So the earth is around 3.5 times larger than the moon. Okay. And the mass of the moon is only 100 times the mass of the earth. Earth is 100 times as massive as the moon. And the moon is really far away. The moon is 384,000 kilometers away. And it's so far away that light takes around 1.3 seconds to travel from the moon to the earth. Now, light takes 8 minutes to travel from the sun to the earth, because the sun is 15 crore kilometer away, whereas the moon is only 3.8 lakh kilometer away. Okay. And therefore, just to give you an idea of scale, I've shown the earth and the moon to scale both in size and distance. So if you consider the earth of the size shown, then the moon will be of the size shown on top right, which is 3.5 times smaller, and the distance also would be this small. So in many images, like even the image I showed, for example, here, right, we always show the moon and earth to be roughly similar size in your geography textbooks. That is not true. The distance and size of the moon is this much to scale, right? So the moon is really, really far away, and it's very, very tiny. It's around 3.5 times smaller than the earth. Okay. Even though the moon is so tiny and so far away, the moon is able to cause eclipses on the earth, and that's what we're going to talk about now. Okay. Before we go there, I want to talk about a cosmic coincidence. Okay. What is this cosmic coincidence I'm talking about? Now, the sun is 400 times as big as the moon. Okay. So if you look at the size of the sun, it's 400 times as larger than the moon. The sun is also far away. If you ask me how much farther away is the sun to us compared to the moon, by coincidence, it is also 400 times farther away from the earth compared to how much farther away the moon is, right? Now, this is a coincidence, just happens to be true at this point in time. Okay. Because of this, because the sun is as much bigger than the moon as it is farther away, they both look the same size on the sky. Now, one way to understand it is that if I take, let's say, a football, right, or a really large beach ball, a large ball, like, one of those bouncy balls you have, right, and if I keep it, and if I keep next to it a small mustard seed, obviously the mustard seed is much smaller than the football. But if I take the football farther and farther away, and I keep the mustard seed very close by, to see, as seen by me, the mustard at some point will look bigger than the football. If I take the football 1 kilometer away, for example, and if I can still see the football and I can see a mustard seed or maybe a jeera seed or something, or a coriander dhania seed next to me, next to my eye, I will see the dhania seed or mustard seed looks larger than the football because it's farther away. But because the ratio of the distance and the ratio of the size between sun and moon is both 400, it so happens that the sun and the moon have the same size on the sky as seen by the earth. This is the cosmic coincidence. Now, why does it matter? It matters because the moon, though much smaller than the sun, is much nearer at the exact scale of 400, that you get this fantastic phenomenon called a total solar eclipse, right? So I'll talk about solar eclipse in a bit, but all of you know a little bit about solar eclipse, I'm sure. This is a photo of a solar eclipse where the moon exactly covers the sun, and you can see the outer atmosphere of the sun called the corona. The corona is the outer atmosphere of the sun, just like Earth has an atmosphere. But because the corona is very, 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 very faint compared to the really bright sun, you need to cover the sun completely in order to see the corona, which happens only during a total solar eclipse. But because the sun and the moon have the same size on the sky as seen by Earth, the moon is able to exactly cover the sun, and we can see the entire corona. This is the wonderful cosmic coincidence which lets us see a beautiful total solar eclipse. Okay. So we know this. Now let's move on to how do you get a total lunar eclipse and a solar eclipse. Now let's look at the solar eclipse first, so that then we can concentrate on the lunar eclipse later. Okay. Now what I'm showing you here is a montage or a collection of photographs. So during a total solar eclipse that happened long back, some photographer who's very famous, he pointed his camera to the sky, and then he makes the sun every 15-20 minutes with a filter, so which cuts out most of the sun's light. Which you see the sun, this is why you see the sun as this orange object. Okay. And then he took a picture of the sun every 15 minutes during the entire total solar eclipse sequence. So now I want you to look at the bottom left image of the sun and then move up slowly. What you're seeing as you go up slowly is that more and more of the sun is being bitten out or cut out by a circle, right? And this circle is nothing but the moon. So when the moon comes exactly between us and the earth, as it moves exactly between us and the sun, it starts covering the sun more and more and more and more and more, till in the middle the moon exactly covers the sun, and you can see this famous corona I told you about for a few minutes. And then the moon will start moving in the other direction as it continues, and then you'll see more and more of the sun coming out, and then at the top right the sun is out of the eclipse. This is what you see during a solar eclipse, a total solar eclipse, and this whole thing takes around 3 hours, 2 to 4 hours in time. Okay, now I'm showing a video taken by by a photographer of an earlier total solar eclipse. Again, the 4-hour eclipse is compressed into a half a minute video so that you can see very clearly what happens. So you're seeing the sun as it is right now, and now the eclipse will begin, and you'll see the moon coming. See, the moon is coming in between us and the sun. It's covering more and more and more of the sun, and then it will cover the entire sun, and then you'll see the corona for a few minutes, right? It's a beautiful corona, and then the moon will keep moving in the same direction, so then it will go away, and then the eclipse will get less and less and less and less, and then the moon will completely leave the sun, right? Now this is beautiful. This video is absolutely beautiful, I think, and it tells you can actually see the moon moving in front of the sun. Now the moon is dark in color because it is in front of, it's between us and the sun. You're seeing the night time of the moon, and therefore it's dark in color, and therefore it will eclipse the sun. When it's fully eclipsed the sun, of course there won't be any light. It will be like night has come on to us, and suddenly the sky will be dark, the birds will go back to the trees, animals will get confused, and all of that happens. There was an annular solar eclipse visible from India in 2021 and 2019. I don't know how many of you saw it, but if some of you saw it, that's fantastic. Okay, so how does a solar eclipse happen? As the moon goes around the earth, sometimes it comes exactly in between the sun and the earth. When it does so, the shadow of the moon will fall on the earth, which I marked as penumbra and umbra. The central shadow is called umbra, that's dark, and the outer lighter shadow is called penumbra. Now, as the moon goes around the earth, the penumbra and umbra will sweep across the earth over a few hours, and as in your and as as the penumbra crosses your location, you will see the moon slowly start eating into the sun, like we saw before, more and more and more and more. And if you are lucky enough that you enter the umbra of the moon, then you get a total solar eclipse for a few minutes, because the umbra is so small on the earth's surface, it only lasts for a few minutes. And then you'll move into the other side of the penumbra, and then you'll have again a partial eclipse of the sun, and then at some point it will go away. These are examples. This is an image of a partial solar eclipse where you're sitting in the penumbra of the moon. You're not able to see the fully eclipsed sun, but you're seeing some of the sun being eclipsed by the moon. This is an annular eclipse, which is what was seen in 2021 and 2019 in India, where during a total solar eclipse, the moon is slightly closer to us or farther away from us than usual. If it is slightly farther away from the earth, it will be slightly smaller. If it is slightly smaller, it will not be able to hide the sun completely, and therefore you get a small ring of light. This ring of light is called the annular solar eclipse. Okay. And then these are examples of past total solar eclipses where you can see the corona during the totality. Here is another set of photographs from another total solar eclipse from from some other site, where again you can see that the moon is moving into the sun more and more and more and more and more, and it completely covers the sun. You get this corona, which is beautiful, and then it goes away, and then it goes on the other side, and then the eclipse finishes after a few hours. If the moon is slightly farther away in its orbit around the earth than usual, then the moon will not be, it will be slightly smaller, and therefore it will not be able to cover the sun fully. And then you get this annular solar eclipse, where at mid eclipse the moon covers the sun but almost, but not quite, and you get this ring. It's called the ring of fire. And then this ring of fire in Kannada you say Valaya Surya Grahana, right? And that ring of fire lasts for a few seconds, and then the eclipse progresses. Okay. Now I told you all this. Now you might be like, oh, why should I believe you? Is there any proof? You're saying so, this is your theory. So I'm showing you evidence. So during a total solar eclipse, which happened on 29th March 2006, astronauts on top of the International Space Station, I think all of you know the International Space Station by now, Shubhanshu Shukla spent 2 weeks there last month, very famously from India, right? And they looked at the Earth during the total solar eclipse, and they photograph the umbra of the moon. You can see here, right? So what you're seeing here is the shadow of the moon, the dark umbral shadow of the moon falling on the part of the earth. So they're actually able to take a photograph of the moon shadow on the earth. And if you are living in one of the areas in this dark shadow, you'll be experiencing a total solar eclipse. Now, on another satellite during another total solar eclipse, they managed to take a video of this as well. And this is what you see. On 9th March 2016, there was a total solar eclipse. And from the satellite of NASA called Discover, they took a series of images as the total solar eclipse progressed, as the shadow of the moon went across the earth. And that is what you're going to see now. I think this is fantastic. This is beautiful, right? I just love this video because it tells you can actually physically see the shadow of the moon going across the earth. And every place, whenever, if you're living on under this dark spot, then you're experiencing a total solar eclipse at that time, right? Okay. Now we're going to jump. Now, what is this? I suppose you all can recognize the moon, but I'm showing you 9 moons. So what has happened is a photographer has pointed the camera at a point in the sky and taken one photograph of the moon every 20 minutes or 15 minutes. But this was taken during a lunar eclipse, a total lunar eclipse. Therefore, this you can see the moon moving into a much larger semicircular shadow or a dark circle. That semicircular dark circle is nothing but the Earth's shadow. And this photograph I like a lot because it clearly shows you how during a total lunar eclipse, the moon is moving into the shadow of the earth and then moving out of the shadow of the earth. And as it moves into the shadow of the earth, more and more of the moon will be covered by the earth shadow. It'll be darker, darker, darker. And then at some point, the moon will come totally into the shadow of the earth. And then you assume that it will be completely black and disappear, but it looks red, which is strange. I'll tell you why it's red. And then it will move out of the shadow of the earth. Now, shadow of the earth you can see is bigger than the moon. It's around 2.5 times as big as the moon. And the moon can, in this case, the moon is going through the edge of the shadow of the earth. Sometimes the moon can go through the middle of the shadow of the earth, in which case eclipse will be longer in duration. These are examples, photographs from Ajay Talwar of past eclipses. And he's again taken 3 photographs before, during, after, and put them together so that you can make out the shape of the Earth's shadow, which the moon is going into, getting completely covered by, and going out of. Therefore, now let's look at, now I think we understand enough about eclipses, but let me look at this again. So when the moon is on the other side, when the Earth comes between the sun and the moon, when the Earth's shadow falls on the moon, you get a lunar eclipse, right? Now, just like the moon shadow had an umbra and penumbra, the Earth shadow also has an umbra and penumbra. But because the Earth is much bigger than the moon, the Earth's umbra is bigger than the moon, which is why the Earth's umbra, in fact, is 2.5 times bigger than the moon. You're seeing the Earth's umbra here, it's much bigger than the moon. Therefore, the total lunar eclipse phase lasts much longer than a total solar eclipse phase. Let me show you the total solar eclipse phase again. Here, because the moon is smaller than the Earth, the moon's umbra on the Earth, or the moon's shadow on the Earth, is much smaller than the Earth. Whereas, therefore, only a small part of the Earth can experience total solar eclipse at any given time. But because the Earth is much larger than the moon, the Earth's umbra or the Earth's shadow is bigger than the moon, and therefore the moon will experience a total eclipse for much longer. Okay. Now, what will happen here again is the moon will enter the Earth's penumbra. But then when Earth enters the Earth's penumbra, the moon's brightness will reduce only by a few percentage. Okay. So when the Earth is in the penumbra of the moon, it's very, very, very difficult for us to notice the few percentage dimming of the moon with the naked eyes. If you have a telescope, you can make out, but then with the naked eyes, you can't make out. So we ignore the penumbral lunar eclipse. Okay, we only care about the umbral lunar eclipse. So when the Earth starts entering into the umbra, you will see that when the moon starts entering into the Earth's umbra, you will see the Earth shadow entering the moon's surface, moon more and more and more. It will cut out more and more and more of the moon till it enters completely into the Earth's umbra. And then you have a total lunar eclipse where the entire moon is eclipsed by the Earth. And then it will spend some time moving through the Earth's umbra. And then it will start leaving the Earth's umbra on the other side, when you will see the Earth shadow again moving out of the moon, and then it will go to the penumbra, which you can't see well, and then it will go off on its path. It is what I've shown here. So when the moon is in the penumbra of the Earth, there will be a slight dimming which you can't tell. But when the moon is entering the Earth's umbra, that is when you can see a beautiful partial lunar eclipse with your own eyes, which is what you're going to see on Sunday, next Sunday, 7th September, as more and more of the moon gets eclipsed by the Earth, or more and more of the moon is covered by the Earth's shadow. And then when it's completely inside the umbra, it experiences a total lunar eclipse. Okay, now I'm going to show you again from the same photographer a video. Okay, and I'm going to play it from here. Okay, so this is the moon. This occurred in 2011, the lunar eclipse. So he just photographed the moon, Ajay Talwar and Neelam Talwar together. And that's a full moon, right? You have a lunar eclipse during full moon because the Earth has to be in between sun and the moon. Now you can see the eclipse started already. The moon is entering the Earth's shadow on the left side, and it's getting more and more and more eclipse. So it's entering the Earth's umbra, right? You can see the Earth's umbra moving across the moon more and more. Now half of it is gone. Suddenly brightens because they changed the camera setting. That's all. Okay. And then most of the moon is now inside the umbra. And at this point, now the moon has completely entered the Earth's shadow or the Earth's umbra. It's experiencing a total lunar eclipse. It will then go through the umbra. It will experience total lunar eclipse for between 1 hour and 2 hours, depending on which eclipse you're talking about. And then it will start leaving the Earth's shadow on the other side. Now you can see it's already left the Earth's shadow more and more and more and more and more. He will adjust the camera setting in a minute. So now it's easier to see. The Earth shadow is moving away, and then the moon is exiting the Earth's shadow, right? And the eclipse is slowly getting progressively more and more. And then the eclipse it has now left it has left the Earth shadow completely, and the umbral eclipse is over. Okay. Now, what did I say? Initially, we talked about, if you look at, sorry. Yeah. So we talked about phases of the moon, right? And we said that a full moon happens if the Earth is between the sun and the moon. So we can see the sunlit part of the moon. Now it's half moon. It's called the first quarter. Crescent. The sun is on the left side. And when the moon comes between the Earth and the sun at now, you see new moon because you see the night time of the moon and so on. But I also told you that when the moon comes between the sun and the Earth, you get a solar eclipse. And I told you when the moon comes between the Earth comes between the sun and the moon, you get a lunar eclipse. This is confusing. So why don't we get an eclipse every new moon and full moon, right? So this is in this situation, the Earth is between the sun and the moon. We should see the entire sunlit part of the moon. It should be a full moon. So every full moon should become a lunar eclipse, and every new moon should become a solar eclipse. But that doesn't happen. You got a new moon and full moon every month, but a solar lunar eclipse, it happens, once every, many months on somewhere on Earth, and at a given location every few years, right? So that is because now the Earth goes around the sun in an orbit. It's called an ellipse, but it's almost a circle. Now that the orbit or the path of the Earth around the sun you can imagine the plane in which it does it, the flat surface on which the Earth goes around the sun. Now the moon goes around the Earth also in an elliptical path, and you can imagine the flat surface on which the moon goes around the Earth. Now these two surfaces or orbits don't coincide but are inclined to each other at an angle of 5 degrees. Okay, and this is the important part. Because it is not a 0 angle but 5-degree angle, if you look at the bottom figure, sometimes the moon during new moon, when the moon comes between the Earth and the sun, it doesn't come exactly in between the Earth and the sun, but it passes slightly above or slightly below. And then you get a new moon because you're seeing the backside of the dark side of the moon. And when the moon is on the other side, sometimes because of this 5-degree tilt, the moon doesn't come exactly in line with the earth and the sun. Instead, it passes slightly below or slightly above by a degree, 2 degrees, 3 degrees, maximum 5 degrees. Because of that, you only get a new moon and full moon. But very rarely, they have to come exactly in line, and only then you get an eclipse. So when the moon is roughly between the earth and the sun, you get a new moon. The moon is roughly, on the other side of the earth from the sun, you get a full moon. But only when the three objects come in an exact straight line can you get an eclipse, which is why the eclipse is very rare and doesn't happen every 2 weeks. If it happened every 2 weeks, I think it'd be beautiful, but it doesn't because of this 5-degree tilt. Now, if you look at the top right figure, I've shown you how it looks from the earth. Now the earth goes around the sun, and therefore if you sit on the earth, it looks as if the sun goes around us once a year, and the constellations through which the sun goes around us in the sky we named Aries, Taurus, Gemini, Cancer, Leo, Virgo, and we call the zodiacal constellations. And this is the path. So this is the path of the sun around us in the sky, which is reflecting the path of us around the sun, but the same thing, right? Now, the path, and that is the yellow line on the top right figure. The gray line is the path of the moon around the earth. And you can tell that they are inclined at 5 degrees and they meet at 2 points. One is called ascending node, other is called descending node. These 2 points I'll come to at the end. So remember these 2 points. Okay. Now, I usually ask it as a quiz, but since we're not here in Zoom, I'll just tell you the answers directly. So I usually ask us a quiz saying, what are we seeing, right? Now, the top left part, the answer, of course, is a gibbous face, right? Because you're seeing the gibbous moon. But the top right part can never be a gibbous face because look at the curvature of the shadow. The top right part is the start of a lunar eclipse. The third figure, bottom left, is a crescent moon. And if you look at the fourth figure, it looks like a crescent, but the curvature is more. That's because Earth's shadow is larger. And that's an almost eclipse moon. So though the crescent moon and the almost eclipse moon look roughly similar, the gibbous moon and the start of the eclipse will be opposite curvature, opposite direction in which the shadow is curved. And that's something to keep in mind, because when you see the gibbous moon usually now and then throughout the year, and you see the lunar eclipse on 7th, you should be able to tell the difference and the reason why. Okay. So these are the top line are the phases of the moon. You can see the shape of the moon as it changes from new moon to crescent to quarter to gibbous to full moon to gibbous to crescent and new moon again. And the bottom is the eclipse, where you can see the shadow of the earth is always a circle, and therefore the curvature, sign of the curvature sometimes changes. Okay. I've been telling you again and again, I've been showing you images again and again where the totally eclipsed moon is red in color rather than black. And you must be wondering why. Because during a total solar eclipse, you saw that the earth shadow is black on the moon shadow is black on the earth. But then during a lunar eclipse, our shadow is on the moon. But then you don't see the moon being black completely. It should be like new moon, it should disappear. But I'm saying no, it is deep red in color. Sorry. So why is that? That's weird. So let's see why that is so. And this is beautiful. So I'm showing you images from 4 different eclipses. And you can see that not only during the total lunar eclipse, the moon is red in color, the shade of red also varies, right? Sometimes deep red, sometimes orange red, sometimes kind of dark red. So the shade of red also varies. If you ask me what is the shade of red on Sunday 7th, I do not know. It's very difficult to predict the shade of red. We'll have to see it to find out. And I'll tell you why. Now, some of the older students here might have studied about why the sky is blue. Now, let's look at it very briefly. Now, the Earth's light, the sunlight comes into the Earth, and that's how we see everything around us. But we see the sky is blue, right? The sky is always blue in the daytime. And when the sun is rising or setting, it's reddish in color. When it comes up, it becomes yellowish white. Now, the reason the sunrise and sunset are red and the sky is blue is the same reason. So sunlight has a lot of all the colors, right? We say rainbow or vibgyor and so on. From blue, violet to blue to green to yellow to orange to red. And our atmosphere, which is a thin layer around the Earth, which is seen in this figure in this blue, light blue shading, has a lot of dust and molecules, right? And the dust and molecules, when the sunlight hits them, sometimes they will scatter it in some other direction. Okay. Now they scatter the bluer light of the sun everywhere. Okay. And the redder light doesn't get scattered, it mostly goes through. Now, because of this, because the dust in the atmosphere and molecules take the bluer part of sunlight and sends it everywhere, and it comes back to us from the sky looks blue everywhere. That blue light of the sky everywhere in the daylight is actually sunlight, the bluer part of sunlight that's taken by our atmosphere and put in all directions. Okay. And therefore, and you can imagine, you can draw a figure at home and see it. If you're looking at sunrise and sunset, the light of the sun passes through more of the atmosphere than if it is overhead, and therefore there's more scattering at sunrise and sunset, and therefore much more of the blue part of the sunlight is taken away by our atmosphere, and therefore the sun looks redder during sunrise and sunset. Now, during a total lunar eclipse, something beautiful happens. Of course, the Earth shadow, the umbral shadow is on the moon. Like you see here, the moon should be completely dark. But while it is exactly behind the Earth, some of the sunlight, some of the red part of the sunlight, which you see as sunrise and sunset, which goes through the atmosphere of the Earth, can refract, can bend and fall on the moon. This is why the total lunar eclipse is red. So the red color of the total lunar eclipse is basically the red color of, when it goes into the umbral shadow, the red color of the total lunar eclipse is due to the red part of the sunlight, which is refracted by the thin atmosphere of the Earth onto the moon. The bluer part of the sunlight is scattered into the Earth's atmosphere itself. The red part goes through and can be refracted. Now this happens. Now therefore, what you're seeing on the moon is basically all the sunrises and sunset light of the Earth at that time. Some of it is refracted onto the moon. And because if there's more dust in the atmosphere, there'll be more redness. Since we do not know how much dust there will be on 7th September, we do not know exactly how red it will be, and we'll have to watch, okay, and see for ourselves. Okay, now let's come to what actually we will see on 7th September. Now we have known, now we know all the phases of the eclipse very well. Now look at the numbers on the right side. Okay, so on 7th September, this is for Madurai, but this is true for all of India, of course. On 7th September night at 8:58 p.m., the moon will enter the penumbra. But penumbra of the Earth is very light, therefore you won't really see it. Okay, so for us the important time is 21:57, 9:57 p.m. on the night of 7th September, 3 minutes before 10 o'clock at night, you will start seeing the Earth shadow come into the moon, or the moon will move into the Earth shadow. Then more and more and more and more of the moon will get covered by the Earth shadow from 9:57 p.m. till 11 p.m. At 11 p.m., the moon will completely enter the Earth shadow. So it takes 1 hour to cross fully into the Earth shadow. And then from 11 p.m. till 12:22 in the morning of 8th September, so almost 1.5 hours, right, or 85 minutes, it will spend traveling through the umbra or through the shadow. At this point, from 11 o'clock till 12:22, it will be dark red in color because it's completely eclipsed, except that some light comes through the atmosphere of the Earth and falls on the moon. At 12:22, it will start leaving the Earth shadow or the umbral shadow, and you'll see the shadow of the Earth leaving the moon slowly, and it will completely leave the moon at 1:26 in the morning of the 8th. And then, of course, it will leave the penumbral shadow, which we don't care about, and then it will go on its way. So this is what you're going to see on the 7th. Now, so therefore, let me show you a simulation of what it will look, right? So this time is important, right? So partial begins at 9:57. Full total eclipse begins at 11 o'clock, ends at 12:22, and the partial ends at 1:26. Therefore, this simulation, the moon first enters Earth's penumbra. Therefore, we don't care because very, very slight dimming of the moon, which you cannot make out with your naked eye. Now at 9:57, it will start entering the Earth's shadow. And then you'll see the shadow of the Earth cover more and more and more and more of the moon till at 11, and then at 11 o'clock, it will completely enter the Earth shadow. It will spend the next 85 minutes looking dark red, moving through the Earth shadow till at 12:22 a.m. It will reach the other side of the Earth shadow, and then it will start exiting the Earth shadow. The partial eclipse will start till an hour later, around 1:22 a.m., when the moon will completely exit the Earth's shadow and the eclipse will then be over for practical purposes. This is what you're going to see on the 7th of September, Sunday. So what all can you do now? Of course, you should go see it, right? That's the most important thing. Can do something more. So you can make your own cutout like this. You can make a printout of this where you can take the actual image of the moon, make multiple copies, and then every 15 minutes you can draw yourself. You can yourself take a dark, black pen. Every 15 minutes you can look at the moon on the sky, look at the eclipse moon on the sky, and then you can exactly try and mark. Since the features are marked, you can correlate the features seen here with the moon, and you can mark the dark part, the eclipse part of the moon every 15 minutes, and then you have a nice record, your own observations of the eclipse, and you can compare that with predictions and say, hey, look, at a really good job. Right? That's something you can do. The other thing you can do, of course, you want to also have fun doing this, and therefore you want to recreate the eclipse. How do you do that? A simple thing is you can use a cream biscuit. So I like Oreo biscuits because the contrast between white and black is very nice. So every 15 minutes you can draw this, and then you can look at the moon and say, I'm going to bite the white part so that it resembles what I'm seeing in the sky. And then you can show your friends and family. And if you've done it really well, you can eat it, right? And then you win. And then you can do it every 15 minutes. But you can also do the same thing with idlis, of course. So we've done this in Bangalore a couple of times. We have 15 idlis or 10 idlis, and every 15-20 minutes you take a bite of the idli to make it look like what you're seeing in the sky. Now, of course, total lunar eclipse is bright red. So then at that point, you can put idli poti or sambar on it or your favorite thing, and then it looks bright. So there's all fun things for you to do at home during the eclipse, right? Now, you can also draw the shadow of the eclipse and try and see how big it is. Now, this eclipse is going to happen on 7th September. There'll be a partial eclipse again next year, but there's only a partial eclipse, so it's going to be not very great to see. The next total eclipse of the moon seen from India is on 31st December 2028. So that's 3 years from now. Of course, it will make for a lovely New Year party. You'll have a new eclipse New Year party, but they have to wait for 3 years, which is not nice. Which is why it's important that you don't miss this eclipse when you see it, right? Of course, we have monsoons in India right now, and therefore it's cloudy in many parts of India, I know. But let's take a chance. Let's go out and see and wait. So if the cloud clears, then you see the eclipse even for some time, and that's fantastic because as the photographs I've shown you clearly show you, the eclipse is a beautiful thing to see. So you should see it. Okay, I'm going to end with this. Now, people will say, don't look at the solar eclipse with your eyes. And that's true. Because if you cannot look at the sun directly with your naked eyes, with your eyes directly during a daytime normally, because sun is too bright, it will harm your eyes. During a solar eclipse also, even if part of the sun is covered by the moon, the remaining part of the sun is bright enough to affect your eyes. Therefore, we always tell people, do not look at a solar eclipse with your eyes or through a telescope or binoculars ever. That will damage your eyes significantly. The special solar eclipse glasses, which you can wear, which will block out 99.999% of the sunlight and let in only a little bit so you can see the eclipse well. But lunar eclipse, even that problem is not there. The brightest the moon can be is during a full moon, and full moon we can see with the naked eye. Nothing happens to our eye. It's not that bright. And lunar eclipse is only going to be less bright than the full moon. And therefore, it's perfectly safe to see the lunar eclipse with your eyes, through a telescope if you have a telescope, or through a pair of binoculars, and there's absolutely nothing to worry about. We also now know that eclipses are only a play of shadows, right? Either the shadow of the earth falling on the moon or the shadow of the moon falling on the earth. And therefore, it cannot cause any harm. How can a shadow cause harm? If I'm standing in the shadow of a building or a shadow of a tree, nothing happened to me. Same way, if I'm standing in the shadow of the moon, or if my shadow falls on the moon, nothing will happen. It doesn't matter at all, right? Now, but then there are a lot of beliefs across the world which say, no, it's not safe. You shouldn't eat or drink or etc. And there's no scientific basis to it. The reason these beliefs came is because thousands of years ago, across the world, in every country across the world, when people did not understand what caused an eclipse. Suddenly, in the middle of the day, the sun disappears for some time and comes back again. Suddenly, in the middle of the night, the moon disappears, becomes blood red and disappears again, and now comes back again. People will get scared. And then, therefore, if you get scared, you say, okay, let's not go out or something is weird is happening. I know, for example, and in China, there would be drums to chase away the dragon they believe swallow the sun and the moon. In Vietnam, they thought a dog or a wolf swallowed the moon. In the Americas, they thought that a bear swallowed the moon, etc., etc. And in India, we have our own stories as well. If you do not understand what it is, you will be scared, and then you'll also think of a story to try and explain it. But then we now know, not only do we now know how an eclipse is caused, we always knew how eclipses caused. In India, for example, in the 6th century AD, 6th century CE, 1400 years ago itself, Aryabhatta, in his work, very famously explained how eclipses are caused. He said eclipses are only the play of shadows, and therefore there's no reason to be scared of it because Aryabhatta himself, 1400 years ago, knew about it in India. Not only did he say eclipses are because of shadows, he also gave equations and algorithms for you to predict eclipses occurring in the future, right? And just like in other parts of the world as well, people then figured out around 1500 to 2000 years ago why are eclipses caused and how do we calculate them. So if you know how to calculate them, because you understand them very well, you understand the motion of the earth and the moon and the sun so well that you can predict eclipses really well. If you can do that, then there's no reason to be scared of them. So there is no reason that you cannot eat during an eclipse or drink or play or even do your homework, do whatever you want to. It's perfectly safe. And lunar eclipse, you can look at it through anything, through eyes, telescope, binoculars. Solar eclipse, you have to be a bit careful and use only the solar eclipse glasses. More importantly, eclipses are beautiful things, and I think you're convinced because I've shown you some amazing images and videos of solar eclipse and lunar eclipse. A lunar eclipse is also so beautiful because it looks deep red in the middle of the eclipse, and these are spectacular, absolutely beautiful natural phenomenon happening very rarely in the sky. And therefore, I think we should not miss it. We should not miss it. We should go see it. We should enjoy it. And we should enjoy it with our family and friends. So do go and talk to your family, talk to your friends, talk to your neighbors, and say, hey, look, I learned about the eclipse. I know what it's about. Let's plan a party on 7th September night. Let's have a party. Let everybody in the apartment complex, gather together in the open or the terrace, and let's all, bring our stuff. Let's all have a party and look at the eclipse together and enjoy it. So that's what I hope you will all do. So with that, thank you. I'll stop. Yeah.
Yeah. So, thank you so much, sir. Your webinar was not only just inspiring, it was absolutely mesmerizing. And I'm sure, our audience have enjoyed it as much as we did. So I think now we can have a small Q&A session, sir. So, our audience was very much actively participating in our YouTube polls and comment section. So we have Mr. Bhupati. So Bhupati, do we have some good questions on chat box?
Yes, sir. Just a second.
Yeah.
So will you read them out?
Yeah.
Yeah.
We will read them out, sir.
Okay, fine.
So one question, sir. If the orbit is 5-degree tilted, then why do we have eclipses at all? Like, shouldn't the shadow miss all the time?
Okay, that's an excellent question. So the 5-degree tilt is there, right? So when the moon and the sun, let's say you have a total solar eclipse happening, or let's say a new moon where the moon is between us and the sun, right? And so the sun is here, the moon is here, and because the 5-degree tilt, sometimes it can go around 5 degrees, slightly above, slightly below, or sometimes it can go this way. It depends on the orientation of the 5-degree tilt with respect to us. So what I can do is maybe I'll share this again, but not do full screen. That's fine. And therefore, I didn't show you this figure. So this figure should remind you of the figure for seasons because it's a bit similar in concept. So what you're seeing flat is the orbit of the Earth around the sun. Sun is the center. Now you're seeing the four things. The four planes are the orbit of the moon around the earth, 3 months apart. If you look at the left and the right, the left and the right, which are 6 months apart, you'll see that the shadow of the moon just about misses the earth and the shadow of the earth just about misses the moon, because the inclination is like this, right? And then you get only new moon and full moon. But if you look at the top and bottom part, then the inclination is such that this actually cuts the flat plane of the Earth's orbit around the Earth, and then at these two locations, the shadows of one will fall on the other. Now, I told you, remember, I said 2 points of intersection. Those 2 points of intersection of the moon's orbit around the Earth and the Earth's orbit around the sun in Indian astronomy are called Rahu and Ketu. Now, Rahu and Ketu, of course, there's a story about Rahu and Ketu causing eclipses, but we know the story is a story. If you look at the Indian science, Indian astronomy, Aryabhatta said, okay, Rahu and Ketu are the 2 points where these two circles intersect, and then he would then tell you how to calculate the position of Rahu and Ketu, which will tell you when the eclipse will occur. Okay, so this is the reason it happens, which is why it happens. So therefore, if it happens on the top figure, you get an eclipse. Then 6 months later, in the bottom figure, you get an eclipse again, because the inclination is just right, and which is why. But it's not exactly 6 months. It actually is 5 months and a few days for some other reason I won't go into. Which is why, if you look at the calendar of eclipses, the white circle is solar eclipse and dark circle is lunar eclipse. You find that they occur 6 months apart, roughly 6 months apart, but little less than 6 months apart, because this is why every year they keep moving back a little bit, right? And that's because they occur 5 months and so many days apart. And that is, this 5 months and so many days apart is basically the top and bottom positions, which is when you have the eclipse season, basically. Okay? Yeah.
Okay. Perfect, sir. Perfect. I'm sure our audience has got the answers correct. So another question do we have? Is what kind of scientific studies we can conduct during this total lunar eclipse with the basic equipment?
Okay. So we understand eclipses really well. So there's not, but then there are some things scientists still do. So for example, total solar eclipse, you can see the corona. Now we have technology, we have telescopes called coronagraphs, which are in space mainly, which will artificially block the sun, so you always can see the corona. Okay, but then it's very difficult to do that. You can block the sun, but you cannot block the sun very closely. You have to block the sun a lot farther apart, and then you see the corona much farther apart. But a total solar eclipse is a great occasion where you can see the corona entirely from the Earth, where you have these huge telescopes, right? So solar astronomers even now love total solar eclipses, because they can study the corona for those few minutes really well with all their telescopes or instruments. They look at the structure, they can look at the polarization, they look at the magnetic field and compare them with theory. So even now, for example, during total solar eclipses, solar astronomers around the world, including in India, look for the corona to study the corona and match it with theory. Lunar eclipses, there's not that much new science to be done, right? But I want to tell you something very interesting, which has a connection again to Indian history and world history also. Now, in various parts of the world, including in India, there have been records of past historic eclipses. Maybe an eclipse happened, in 10th century or 6th century. And in India, we have records up to almost 2000 years. But then in Babylonia, Mesopotamia, and China, we have records of eclipses going back to 1500 BC. So more than 3000 years ago. Now, if you then look at, now we know how to predict eclipses because we know the motion of the moon and sun and the earth really well. And therefore, but then our prediction accuracy becomes less and less the farther back in time you go and the far more forward in time you go. If you want me to predict an eclipse will happen 10 years from now, I can predict it with accuracy of a millisecond. Okay. If you ask me about an eclipse which happened 100 years ago, I can predict the accuracy of a millisecond, maybe. But if you ask me if an eclipse happened 2000 years ago or 2000 years later, the accuracy will be only a few seconds, not a few milliseconds. And the reason is that the Earth's rotation speed changes slowly with time. The moon's orbit slowly changes with time, which we do not know very well. Therefore, what people have been doing in India and outside other countries is they look at the old historic records of eclipses and then compare with our current predictions of those eclipses in the past, and you'll see a few seconds difference or you'll see a few kilometers difference in where it happens. From there, you can infer how the Earth's rotation or the moon's orbit has changed over time, which I think is really fascinating, right? So eclipses are still very, very important for us, but even historic records of eclipses are very important, not just the current eclipses, right? But it's not just about finding something new. It's also about you doing something on your own, right? So this activity I showed you can do on your own and compare with predictions, and you can say, hey, look, I did a really good job in marking the eclipses. You can also, what you can do is you can draw the moon and you can try and measure the shadow diameter, right? You can search online the various ways of doing it, and then you can see if that matches the prediction. And you can be, hey, look, I did a really great job, right? And so you can do a lot of activities yourself even now, which may not be totally new, but new for you. And there's something you can do afresh with your by your own hands and eyes. And that I think is really cool also.
Wonderful, so wonderful. I think this is going to be a great point. Where the students must realize how important our old datas are, and how what else we can learn from our old data, and of course add it in our modern science.
Exactly.
So excellent, sir. Another question that we have, so, is why do we get annular solar eclipses when we have total solar eclipses? Can we, as a student, predict what kind of eclipse we do get beforehand?
Okay. So the moon's orbit around the Earth is not a perfect circle. It's an oval. Okay. The oval, the shape is called an ellipse in geometry. Some of the older students here might have studied ellipses in school. And the fact that all orbits around the sun and around the Earth, etc., are ellipses was first said by Kepler long back, right? And then later, of course, Newton proved it. Now, if the moon's orbit around the Earth is an oval, it's not a very narrow oval. It's almost a circle, but slightly squished. Okay. And that means during its orbit around the Earth, its distance from the Earth keeps changing slightly. Slightly means by around 10-11% only it changes. Okay. Which means sometimes it's slightly closer, sometimes it's slightly farther. If it's slightly closer, it will look slightly bigger. If it is slightly farther, it looks slightly smaller. If a total solar eclipse happens when the moon is slightly closer, it is big enough to cover the sun, and you'll get a total solar eclipse. But if the total solar eclipse happens when the moon is slightly farther away from us, then it will be slightly smaller, and by this coincidence I told you about, it is slightly smaller than the sun. Small enough, not too small, but small enough that it covers some 95 to 99% of the sun. And therefore, at mid eclipse, if you're exactly in the middle, it will leave a small ring of the sun uncovered, which is an annular solar eclipse. Okay. The interesting thing about it is also that the moon is moving away from the Earth slowly. Okay. It's not moving very fast. You don't have to worry about it. The moon is moving away only at a very slow speed of 4 centimeters per year. Okay. But after a million years, that is 4 million centimeters. After 100 million years, is 400 million centimeters. So after, let's say, a few 100 million years, the moon would have moved away enough that it will be too small to ever cover the sun. And therefore, you'll never have a total solar eclipse after a few 100 million years. That is the sad thing. But then that's much in we don't care, right? It's much in the future. But roughly 1,000 million years from now, you'll never have a total solar eclipse because the moon is moved so far away that it will never be big enough to cover the sun on the sky. But right now, because it's just about right, we have both total solar eclipse when the moon is exactly the size of the sun or slightly larger, or annular solar eclipse when the moon is slightly smaller than the sun, when it is slightly farther away from the Earth.
Amazing, sir. So we can say that we are living in a golden era of science, where we can unravel the universe mysteries and understand.
So this is the cosmic coincidence I talked to you about. But the cosmic coincidence lasts for a few 1,000 million years. So it's not it's not like too much of it's not like, oh my god, no, in 10 years there won't be anything. But
Yes.
many 100 million years, this is roughly true. Okay.
Got it.
Yeah.
So we have one more question from one of our students. Is what is the difference between blue moon and blood moon and pink moon? Because they keep hearing all of these terminologies, over internet.
It's a bit confusing and it's slightly silly because the media goes completely berserk saying, oh, blood moon, blue moon, then hunter moon, wolf moon. I can't even keep track of all the names they keep coming up with. Okay. So a lot of the names for different moons of the month, like wolf moon, harvest moon, etc., comes from a particular farming tradition in the US. So that's just very recent. So we'll ignore that. Okay. Now, a blue moon has a specific meaning. It's not actually blue. The moon doesn't become blue. It's just that now new moon to new moon and a full moon to full moon takes 29.5 days. Sometimes if you start with a full moon on the first, then you can have after 30 days, you have one more full moon in the same month. That's called a bloom. That's all, right? So 29.5 days, it will never align with the month exactly. It will be like this or like this or like this or like this. The 29.5 is less than 30 or 31. So if it exactly fits into that month, you'll have two full moons, and that's called a blue moon. Okay, because red, nothing to do with the color. Color is there's nothing blue about it. A red moon or a blood moon basically is this when in the middle of a total lunar eclipse, because the red part of the sunlight passes through our thin atmosphere and falls on the moon, it looks red. Therefore people call it the blood moon. I like the color copper moon because I think it looks more copper than blood, and there's no reason. And if they blood moon, people are like, oh, it's scary and all. There's no reason to be scared. So I would like to call it the copper moon because it's kind of copper red color, right? And that's the name. That's why people call it the blood moon or red moon or copper moon and so on. The other names like wolf moon, harvest moon is just some tradition in a particular part of a farming community in the US, which has no astronomical connection. It's just a name. You can give your own name. It's perfectly fine. Right? Okay.
Great, sir. Yeah, so one more question, sir. Is there anything about lunar eclipse that still remains a bit of mystery to the scientists and astronomers?
Okay. So there's no mystery as such. We understand them quite well. The only thing we don't know. So mystery is not the same as not knowing, right?
Yeah.
So I know why the fully eclipsed moon is red, but I cannot predict how red a particular eclipse will be. So if you ask me what is the shade of red on 7th September, I don't know. Why is that? That's because the amount of red light which passes through the atmosphere depends on the scattering, which I told you about. And the scattering depends on the dust. Now, the amount of dust in the atmosphere of the Earth varies with time. Therefore, since I do not know how much dust will be in the atmosphere, what size dust grains will be mainly in the atmosphere, in the limb which is having sunrise, sunset at that moment during total lunar eclipse, I cannot tell exactly how red it is. So we have to go and see it. But it's not as if it's a mystery. I know why it happens. I just don't know how much dust there is because the weather is difficult to predict. That's all. But right? So, but for example, there have been famous examples. There was one lunar eclipse long back, I forget which year, many decades ago, which happened just after a very big volcano erupted somewhere. I think in Indonesia, I'm not sure. Okay, that volcano threw out a lot of dust, which went everywhere in the Earth atmosphere. So entire Earth's atmosphere covered with dust. So that total, because of so much more dust than usual, that total lunar eclipse was almost black, right? It was very, very, very dark red compared to usual because of the dust thrown up by the volcano, which happened just before that, right? So we don't know. So that's something to watch out for and say, okay, let's see what color it is going to be. But that color is related to how much dust there will be on that day, at that time, on the limb of the Earth. That's all.
Understood, sir. So good point, sir. So, sir, does light pollution also affect the viewing of lunar eclipse in terms of the color may get little dilute because of the light pollution?
So not light pollution of view. So because here, if you're looking at the moon during eclipse, you're somewhere on this part of the Earth, right?
Right.
Facing the moon. Now the sunrise, sunset is happening here, and a circle like that, from top to bottom and then back. So it depends on the light pollution on that ring, right? On that ring from here to here and then back again behind the Earth. So it depends on what you're seeing from here on the moon depends on the light pollution here, and not light pollution, but more about the not light pollution, the pollution, dust pollution here. But light pollution really doesn't matter because even the eclipse moon is bright enough. So it doesn't really matter. You'll always see the eclipse moon. If the sky is clear, you see the eclipse moon. But we are having monsoon right now, so we don't know what's happening in different parts of India. But the eclipse moon is bright enough that the light pollution doesn't affect it. But the dust pollution in the limb of the Earth will affect how red you see it. That's all.
Perfect, sir. Perfect. So Bhupati, do we have any more questions coming from YouTube Live? There is a one more question that's if we are standing on the moon during eclipse, during this lunar eclipse.
I usually ask this question when I meet students, but since I'm not interacting students, I didn't ask the question. It's a good point. So during a total lunar eclipse, if you're standing on the moon, what will you see? Can people put their answers on YouTube?
We have done that, sir, and the answer is a glowing red ring around the Earth.
That is true. What other big event would you experience if you're standing on the moon during the total lunar eclipse? Remember, the Earth is between the sun and the moon, right? The Earth's shadow is falling on the moon. So if you're on the moon, the Earth's shadow is falling on you. So what event are you experiencing?
So,
total solar eclipse.
Exactly.
Yeah.
So if you're an astronaut on the moon during a total lunar eclipse, you will experience a total solar eclipse. And of course, the Earth will be surrounded by a small red ring around.
Red ring around.
Hopefully, we'll find an astronaut who goes there during a lunar eclipse and then gives us photos at some point.
Yeah, but I guess Corona cannot be seen, right? During this.
Oh, because the Earth is much larger than the sun.
Yes.
Right? So you can see the corona, outer corona, but not the inner corona. Right? And of course, this red light will also, make it slightly dimmer. The outer corona, you'll be able to see.
There's a one more question that we kept as a poll, sir. So which eclipse lasts much longer? Either it is a lunar eclipse or solar eclipse based on the size of the shadow of Earth and the moon.
So lunar eclipse will last longer in general because the size of the shadow is larger.
Much bigger.
Yeah.
Hi, Bhupati. So do we have any more questions or shall we wind it up?
Yeah, there is one question from Kavita. Oh, she's asking that how did Aryabhatta discover this eclipse? Like, do he have any particular kind of procedure that he came out with, or what else?
Okay. So we don't know exactly because we don't have all of Aryabhatta's works preserved. We lost some of his works. Okay. Of course, people were there before Aryabhatta, right? There were Indian astronomers before Aryabhatta, and there were also Greek astronomers who had come. So Indian astronomers had interacted with Greek astronomy, and therefore we had exchanged a lot of ideas, right? So a lot of ideas went from here to there. Ideas came from there to here. So, for example, the concept of week, 7-day week, or even astrology is believed to come from the Greeks to us, right? So Aryabhatta has built on an older tradition, which we don't have too many records of, unfortunately. But Aryabhatta is famous because of many things. One of the things famous for is, of course, he gave this formula algorithm for calculating eclipses, which we believe is partly based on what he learned earlier, but also a lot of his own research. Right? He was an absolutely brilliant scientist of his age, right? And therefore, we know that he had come up with his own algorithms to calculate eclipses, which would have been much better and more accurate than what was known before that. He also did other things. For example, he was the first person in India, at least, to say that the Earth is a sphere, and we're all standing on the sphere of the Earth, and the Earth is hanging in mid-space. The fact that the Earth is hanging in space, nothing supporting it, is something he said very clearly. He's one of the first people to say it in the world. And I think one of the first people again to say very clearly that the Earth rotates around its axis, and that is why the sky seems to go around us. So those two things also is one of the first people to say very categorically in the world. So he was a very great scientist at that point, both in terms of these conceptual understandings, conceptual leaps, like is the sky is not going around us, the Earth is rotating, or the fact that the Earth is a sphere hanging in mid-space and people don't fall off, but people are all standing on the surface of the Earth, as well as using observations and data and coming up with better algorithms to predict eclipses even more accurately. All of this he seems to have done, very, very well. That's why he's one of the great astronomers of the world, if not India, of that age, right? Of course, many people followed in this Varahamira, Bhaskara, Brahmagupta, Lalla. So many people followed him after that. All
So,
build up. All of them will refer to Aryabhatta. They say, Aryabhatta says this, so I'm adding some correction to it and so on. So everybody follows Aryabhatta in that sense, and then they add to it, they modify it, etc., as they get more and more data over the centuries.
Yeah. So, sir, we also have one more last question that how does any eclipse look from the North Pole and South Pole, if we can?
Okay. So actually, if you look at it, the northern North polar region and the south polar region actually experience a lot more eclipses than the equatorial part. And there's a reason for that, which I won't get into. But it won't look very different, right? So wherever you're on Earth, the moon shadow will either pass on you when you get a solar eclipse, or your shadow will pass on the moon and you see a lunar eclipse. But it doesn't really matter much. The appearance won't change too much depending on where you are on Earth. But the frequency with which you see it from a different given location will depend on your latitude a little bit. There's some dependence on it. But in appearance, it won't look that different. It will be roughly the same.
No, that's it from YouTube, sir. Thank you. Thank you for
Okay.
valuable insight.
You're welcome.
Yeah. So,
So
thank
the
you for your
message now,
explanation.
key message is that very important message. All of you have to go and see it, right? Talk to your family, talk to your friends, talk to your neighbors, organize like a lunar eclipse watch party on 7th September. Go out of your apartment, into the common area, park, whatever, terrace, and see the eclipse. Even if it's cloudy, hang out outside. It might clear for a little bit. When you catch the eclipse for a little bit, also it's fantastic. It's beautiful. So see the eclipse, and after seeing the eclipse, I think there's a way for you to contact Navars, Edutech, and Ashish and tell them you've seen the eclipse. We want to hear back from you and say, hey, I saw the eclipse, it was beautiful. Here's a photograph, whatever it is, right? So, yeah.
So I think, sir, that would be, I think the most highlighted point of this webinar, because, sir, as an Indian society, people are much more, have this kind of fear. There is a kind of fear element attached with the eclipses, and especially, with our parents and all those things. So I think that this would really, kind of motivate them. So, sir, your explanation, has not only deepened the understanding of this fascinating event, but also, helped us breaking the myths and see the beauty of science in action, sir. I'm sure, our students and participants are now walking away with more curiosity and more, inspiration. So, thank you so much, sir, for
Thanks a
such a
lot. Thanks
wonderful
for attending.
webinar, sir. I really
Thanks
thank
for
you
your,
from our
thanks
Navars
for
team side.
inviting me, and thanks for your time to listen patiently. And I hope all of you get to see the eclipse.
Absolutely, sir. Absolutely, sir. And we are also, sir, organizing this event across multiple states in the country. And we have this activity, where the children has to draw the eclipse basically in in whichever phase they are seeing it. And once we have the report with us, sir, we would love to share with Indian
Please
student
do. I would love to
astrophysicists.
see it. Yeah, thanks. And good luck. Good wishing you all clear skies for 7th September.
Yeah,
And
wish you
hope
the
all
same,
of us
sir.
get to see it.
Thank you, sir. Thank you so much, sir.
Thank you.
Have a nice day.
Thank you. Thank you.